Hello, welcome to part 2 of our lecture in chapter 2 on organizing data. And in section 2, we talk about the idea of how do we organize qualitative data. Even though data variables that are qualitative are not numerical and we can't do many mathematical things with that kind of data, we can certainly do one thing, and that is to count. And just about every piece of organization of qualitative data, that is data without numbers, or sometimes it can be data with numbers depending on what we're talking about, but qualitative data gives us a quality of a place or a thing, is that we can count them. And everything that you'll see in relation to this talks about what do we do with that qualitative data. So we're going to go through a couple of organizing techniques for that. And the very first organizational technique we talk about is called a frequency distribution. And a frequency distribution of qualitative data is basically a listing of the distinct values and their frequencies that occur. So when we talk about frequency distributions, we mean that we're counting how frequently does a piece of data occur. If we were to go through and count, for all of the students in this class, count their hair colors, let's say, and we were to make a count of those, we would getting the frequency distribution of that hair color. Let's talk about another one in an example right here. And the way we're going to do it is this. If we wanted to count up the information that we have, our qualitative information, what we would do is we would actually list the distinct values of the observation in the data set in the first column of our table. So if we had hair color, for example, and we listed black, brown, blonde, red, bald, gray, right? And we just listed those down and just use those as our 6 categories we would want to categorize. That would be our first table list, first list of observations, our first column of that table. The step 2 would be for each observation, place a tally mark. So we would go through and we would just count, right, how many of each of those things occurred. So they're saying take a tally, right? Just tally it up. We're counting, right? If we're doing this by hand, easiest thing, just tally, make little tally marks, little hash marks, 1, 2, 3. I'll show you this in a second. And then count the tallies for each distinct values, and this is going to be our frequency. Well, let's use an example right here. Let's say that we had 40 students in the class, and we asked their political party affiliations. So we went through and they all listed down their party affiliations. No name is attached, by the way, right? Notice we can do this completely anonymously. And we see Democratic, Republican, and other showing up. So it looks like our only categories that we could possibly have in our first column are going to be just that. Either Democrat, Republican, or other. So now we would want to go through, right? Because if we're looking at this table right now, if we're just looking at this massive data, well, it doesn't really do much good for us because it's a little bit hard to make sense of. But what we do with it when we count does make more sense. We see that if we were to go through and one by one count, we would see that the number of Democratic students in this class were 13. If we counted the ones who said they were Republican, we would have counted 18, right? So each, by the way, if you've never done this tally mark thing, right, that's where you count 1, 2, 3, 4 across and put a cross on that, right? And then you get a total of 5 within each group right here. So 5, 10, 15, 18, right? 3 more marks right there in this group right here, 18. We have 9 who responded others. So here's our total frequency, right? This is what we call our frequency table. And all it is just a way of counting. Very simple. And by the way, it makes some sense, right? Already we can see, well, clearly the students who identified themselves as Republican in this class outnumbered those who responded Democrat, but, well, there were still 9 who were identified as others. We don't know what those others are, right? Independents, libertarians, could be socialists, who knows, right? So those Republicans could be outnumbered by a bit more than it looks. Relative frequency, right? What do we mean by relative frequency? Well, if we do our count, our tally, as we did in our last slide right here, right? We're just counting the numbers. But we want to say, well, okay, let's say relative to the entire group of students, what percentage of that group was represented by their relative frequency? So that's one thing that we have to do. We have to look at the relative frequency distribution. And when we say relative frequency, what we do is we're listing the distinct values relative to the entire group. So the way that we do that is, of course, we take a frequency distribution, we make our count like we did with our Republican, Democrat, other table, and then we divide each frequency that we see by the total number of observations. This is actually a really simple thing to do. There were 40 total students in this group, and we counted 13 of them that said Democrat. So if we take 13 divided by 40, we get 0.325. That's the relative frequency. 13 out of 40, or 0.325, is what we consider the relative frequency. When we counted Republicans, we counted 18 out of 40. That comes to 0.450. That is a relative frequency. 9 divided by 40 was 0.225, right? And what should happen in terms of these decimals is if you add them up, you should get 1.000. Now, for those of you guys who don't remember this, I'll be happy to help you. Remember, if we have a decimal form and we say 0.325, right? If we want to convert that into a percent, we're going to multiply that by 100. So we would take 0.325 times 100, right? And as a percentage, we're going to represent that as 32.5%. Percent means per 100. Right? So if you're given a percentage and you want to convert back to the decimal, then we actually go that. Now, we actually divide by 100. Right? Which is kind of weird. But all right, so if I had my 0.225, right, what we're really saying right here is that 22.5% of the class, almost a quarter of the class, said, I'm other. I'm not either one of those things. So that's actually a pretty big percentage considering the entire population. But anyways, this is the idea of relative frequency and a relative frequency distribution. All right, so what can we do with this? Well, a very popular thing to do with this kind of data when it comes to qualitative data is to use a pie chart. Now, the thing you have to be careful of in a pie chart is that we don't start adding on more categories. The categories are fixed, and there's a whole pie worth of information, right? In this case, our class of 40 students, right, that's a very fixed pie, right? So we can divide the disk into wedge shapes that are proportional to the relative frequencies. And the way that we do this is, of course, we obtain our relative frequency distribution, and then we divide the disk into wedge shapes proportional to do this. If you're doing this by hand, probably the best way to do that is to take whatever percentage it is and multiply it by 360 degrees, right? A little geometry right there. Whatever percentage of 360 degrees makes up the angle that you put within your wedge-shaped piece. And then we label the slices with the distinct values and the relative values. So here's an example of this one for our relative frequency table. We see that 45% of the political party affiliations was Republican, 32.5% Democrat, and 22.5% other. While Republicans do make up a big slice here, right? Visually we can see that if you take Democratic and other, they actually dominate the class. So it's an interesting dynamic that goes on right here. When we talk about a pie chart, however, a couple of things that you must note. If you are going to make a pie chart, number one, the pie chart, if you're going to be a good pie chart, is that you have to have some sort of key that labels each of the slices, right? The other thing is that you need to put on the percentages. Right? The percentages are very important right here because the percentages need to be, if somebody is looking at this pie chart, we have to note that those slices actually add up to 100%. If they do not, and by the way, if you ever watch political polling on television, they do this a bit. sometimes they'll fiddle with that kind of thing, and it's very confusing when they do. All right. So good pie chart, flat. You're looking at it straight on, has the percentages and the key or the labels for each of those slices. Another type of chart that we use very often is called a bar chart, and that displays the distinct values of the qualitative data on a horizontal axis and relative frequencies, or the frequencies or percents themselves, the frequencies themselves or percents of those values on a vertical axis. The relative frequency of each distinct value is represented by a vertical bar whose height is equal relative to the frequency. So that's kind of like the wedge of our pie chart. The height of the bar itself represents that frequency, and the bars should be positioned so that they do not touch each other. Right? So if we wanted to go through and make one by hand, we would go through and we would do this by obtaining a relative frequency distribution, applying the procedure that we took. We're going to draw a horizontal axis and place the labels along that horizontal axis. For each distinct value, we're going to make a vertical bar whose height is equal to the relative value, and then label those distinct values on the horizontal axis. So here's an example again with our Democrat, Republican, or other class. And again, we see the height of the bar. Right? We draw the horizontal bar beneath. We draw the vertical line going up and down right here. And our relative frequencies, the highest relative frequency was 45%. So we put 0.5 up here to represent that highest value. We start with 0 at the bottom. And we draw a height equal to that relative frequency. So 0.325, right? Pretty close to 3. It's not going to be exact science if we're doing this by hand. Republican, 0.45, so that's right between 4 and 5 is a height. Other, 22.5, right, just above the 2.2, right? There it is. Okay, so this is a relative frequency table. That's it for our section 2.2. I will separately present a way for you to do this, to generate your own table using table, bar graph, and pie chart using Microsoft Excel, what we call pivot chart. So that should be kind of fun here, and we'll do that separately in another video.